Hello everyone. In a recent video, I went through some 1D list practice problems and their solutions. The 1D list practice problems had us first write code to generate a list that has 20 random numbers. This list was one-dimensional because it didn't have any nested lists inside of it, meaning each element of the list was an integer, not a list. Then using that 1D list, we went through 5 subproblems involving printing out each element in the list all on one line, sorting the elements in the list, printing the largest and the smallest number in the list, determining the number of times a user-specified number is in the list, and then lastly, we wrote code to remove all instances of a user-specified number in the list. What I'd like to do now in this video is resolve these problems as part of a 2D list practice problem. So we're going to up the complexity a little bit here from a 1D list to a 2D list. So the first thing we need to do as part of the 2D list practice problem is write code to generate a 2D list. We'll write code that generates a 2D list that has 10 rows, and each row will have 5 columns. You can think about this 2D list like a table. Imagine working with tabular data in, say, an Excel spreadsheet, right? The data is two-dimensional because it's organized into rows, one row on each line, and then each row has values in it. And those values, if you look down the y-axis of your table, form what are called columns. So we'll think of our 2D list of 10 rows and 5 columns of random integers as a table. So what I'm going to do is I'm going to declare a variable called table, and it's initially going to be an empty list. But this is going to represent our 2D list, aka our nested list, where each element is a row, which is a 1D list of numbers, of integers. Now I'm going to need a for loop that is going to set up a new row to be added to the table. So because I don't need the loop control variable, I or j or whatever we want to call it, I am going to simply use the anonymous variable and say for underscore in range 10. So I need 10 rows, so my outer for loop is going to run 10 times. Each iteration of this for loop will create a new row. Now, because I need to fill each row with 5 numbers, I am going to have a nested for loop that is going to run 5 times. So for each row, I need to generate 5 random numbers. Make sure you import the random module, and then you should be able to call random.ranrange or random.randint. I'll do ranrange here. The prompt says that we should generate random numbers between 1 and 11, inclusive of the 1, exclusive of the 11. Right here, between 1 and 10 inclusive. So this is going to give me 1 to 10 inclusive, aka 1 inclusive, 11 exclusive. If you decide to use random.randint, then you would want to pass in 1, 10 to get 1 to 10 inclusive. But because I'm using ranrange, I'm passing in 1 inclusive, 11 exclusive. You can see this from the documentation here. So now I've got this for loop that's going to run 5 times. Each time it's going to produce a random number. I want to append that random number to the end of row. So if we just look at this code right here, row is initially empty. The first time this for loop executes, we're going to add a random number to the row. That'll be the first element in the row. The next iteration of the for loop will create another random number. We'll append it, so it'll be the second, the last element in the 2-element row. And then the third iteration, we'll add the third element. The fourth iteration, we'll add the fourth element. And the fifth and final iteration, we'll add the fifth and final element, the last value at the end of the row. Now, outside of this for loop, but still nested inside of our outer for loop, we have built a row. What we want to do is we want to append that row to the table that we're building up. So now the first iteration of this outer for loop, table is empty. But once we build up a row, we append that row to the empty table on line 163. And now table has 1 element, which is the first row of the 2D list. The outer for loop will run 9 more times to add 9 more rows. So the last iteration of this outer for loop will be creating the last row and it'll get appended to the very, very end of the table. Feel free to add some print statements throughout our for loops here. For example, printing out row and table and random at strategic spots to help you visualize what this nested code is doing. Now that we're outside of the for loop here, let's print out our table. And we should see a two-dimensional list. So here it is right here. I know it's two-dimensional because I've got a hard bracket for my outer list, and then the first element of my outer list is a list in of itself. So these two hard brackets right here show me that we've got two-dimensional list. So now I could count. So the first row has 5 elements. Awesome. And let's count all the rows, make sure there are 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then here's the closing hard bracket for the last row, which is a 1D list. And then here's the closing bracket for the table, which is a nested list. Awesome. Let's move on to the subproblems. First, number 1, print the numbers in a nice grid format like a table, meaning that instead of having all of our output on one line like this, we want to organize it so that each row is on its own line. Go ahead and pause the video and try out this problem, number 1. If you're feeling pretty confident about your solution number 1, I would suggest that you make sure that you implement it as a function, because having this nice code or function that accepts a 2D list and prints in a nice grid format could come really in handy, because our human visuospatial system is really good at looking at two-dimensional data when it's structured two-dimensionally, whereas we're not so good at looking at two-dimensional data one-dimensionally like I have down here. So try out number 1, try writing your solution as a function, and then feel free to tune in with my solution or carry on with problems 2, 3, and 4. I'm going to write my solution here, not in a function, and then I'll put it into a function. So if I want to print out table in a two-dimensional form, then I need to iterate through each row in the table, and then I need to iterate through each value in the row. I need to print out the value, but I don't want each value to be on its own line. Otherwise, I would have 50 numbers, one number per line. That would be 50 lines or 50 rows of output in my terminal, which would be really difficult to read. So what I'm going to do instead is I'm going to override the default new line that print adds to the end of our output with simply a space. So now each value in the row will just be separated from the previous value by a space. Once I get done printing out all the values in a row, then I'll just print out a plain old new line character so that the next row is on its own line. I'm going to scroll up real quick before I run this, and I'm going to comment out the solutions to problems number 4 and 5 from the 1D list practice problems, just so that I don't have to keep entering inputs every time I want to test my 2D list code here. So let's run this. Make my terminal down here a little bit bigger because we've got 10 rows, which is quite a bit. So here's our output from lines 168 to 171. So I've got 10 lines, and each line has a space-separated list of 5 values. I can make this look even better if instead of entering in a space, I enter in a tab. That'll make our code produce output that's a little bit more aligned. So now you can clearly see this is the first column, this is the second column, this is the third column, this is the fourth column, and this is the fifth column. This looks really, really, really good. Now what I'm going to do is I'm going to indent this code as part of the body of a function. And I'll call this function print table, and it will accept a table and print it out in this nice structure. So the output is going to be exactly the same as before. But now I have this function that I can reuse perhaps as part of my solution to, say, number 4, where I'm going to be modifying the table and I want to print the table out to make sure that it is in fact modified. So just kind of handy to have this function around. I'll put a little note in here that this print table function is not very robust. Simply putting tabs in between our elements only works because right now our elements only have like 1 or 2 characters, meaning 1 or 2 digits in the integers. But if you start mixing in some larger numbers or maybe start mixing in some variable length strings in here, then our print table is not actually going to be a very good function for printing any table with any data in it. So if you're interested in a nice little utility module that will nicely kind of organize or structure two-dimensional data, I would say take a look at the tabulate module for a nice package used for pretty printing tables. You will need to pip install it or conda install it. It is not a standard Python package, but something to look into if you're interested in nicely printing out 2D data for debugging purposes. All right, next. Number 2, prints the largest and smallest number in the list. So a few ways to solve this. If you look at our solution to the 1D list practice problem, we were taking advantage of the fact that our list was sorted, and then we were also taking advantage of the fact that there's built-in min and max functions that we can call. I'd like to stick with this second approach that uses the built-in min and max function. The only issue here is that our table is two-dimensional, so we don't want the min or max of the rows themselves. We want the min and max of the values over all of the rows. So I will still need a loop for this solution. So let's assume the first row's first element is both the smallest and the largest element in the table. So I'm going to have a variable called smallest and a variable called largest, and they're both going to be initialized to table sub 0 sub 0. And I'll just make a little note here that this assumes there is at least one row with one element. So it would be good to probably put a little if statement on here to make sure that there's at least one row and that row has at least one element. Otherwise, if I start indexing into, say, an empty list, this is going to crash my code. All right, so I assume that the first row's first element is the smallest and largest element in the whole table until proven otherwise. So until proven otherwise would be walking through each row in the table, and let's start with finding a new smallest value. If there is a minimum in this row that is smaller than our current smallest, then that means I have a new smallest. So I'm going to overwrite smallest with the minimum from the row. Now I'm just going to repeat this same logic for the maximum. So if there's a maximum in this row that is greater than my largest value I've seen so far, then I'm going to overwrite that largest value with this new largest value. Now outside of the for loop, I'm going to report my findings. So min is 1, max is 10. That makes sense. If you look at how we created our table, we're using random numbers in the range 1 inclusive to 11 exclusive. So 10 would be the largest. Let's say I tried this with 101, just for fun. Let's see what we get. So the min is still 1 and the max is 94. Let's try 1001. So now the min is 2 and the max is 990. So it looks like our code is working. Put that back down to 11, so we get 10 inclusive. And now for extra practice, it would be great to put this solution into a function, and that function could return both the smallest and the largest values using what's called tuple packing and then tuple unpacking in the calling code. So take a look at a previous video I've made on functions for how to return multiple values from a function. All right, let's move on to number 3. Determines the number of times a user-specified number is in the list. Now, I'm going to be a lazy programmer, which oftentimes is a smart programmer, and I'm going to scroll up, and I'm going to simply copy my solution for this problem when we were solving it with a 1D list. Uncomment the code here. So I'm going to prompt the user for a number. I'm going to make sure I store that number as an integer. And then I've got this count variable here where I'm going to go through each element in the 1D list. If that element is equal to the user's number, add 1 to count. Well, what I need to do to adapt this 1D list code to 2D list code is add another for loop, right? For row in table. Now I can simply indent this second for loop so that it's nested. And now for number in row, if that number is equal to user num, then I'll do count plus assign 1. This is my accumulator variable. That's it. So I need this nested for loop here because I have a nested list, right? Two-dimensional list means I've got 2 for loops here in order to iterate over each value. So let's try it out. Comment this out down here. That was a second solution that we used list method count in order to solve the problem with. Okay, so let's look here. 10's pretty easy because it's 2 digits. So here's 110, 210, 310, 410. So let's enter in 10 and make sure we get a count of 4. So it says there are 4 of 10 in the list. Awesome. Now, like I said just a moment ago, we also solved this using numbers.count. So if I want, I'm going to cut this. Instead of having this if statement here and this for loop, what I could do is I could do count plus assign, so accumulate and count row.count user num. And I could actually eliminate one of the for loops if I decide to use this list method here, for which the implementation of count would have some kind of loop in order to go through each element in row and figure out if user num is in there and how many times user num is in there. So let's try this solution a little bit shorter. I'll try it with 10 again, and I see the same result. There are 4 of 10 in the list. So there's 2 ways to solve number 3. Now the last one here, number 4, the trickiest of them all. Remove all instances of a user-specified number in the list. If the number is not in the list, print the message, sorry, your number is not here. I'm going to do the same thing as I did before. I'm going to scroll up and I'm going to copy our 1D list solution where we did much of the heavy lifting to solve this problem and just adapt it for 2-dimensional lists. Uncommenting this, I've got a prompt here. Please enter a number in 1 to 10 to remove, storing that string returned from input as an integer in a variable called usernum. And then I'm testing if usernum is in numbers. And remember, numbers is a 1D list for this particular solution. If it is in the list, then while it's still in there, I'm going to do an item-based removal using the list remove method. But if usernum is not in numbers, then this Boolean condition will be false. The else body will execute, and we say, sorry, your number is not here. So if I'm going to adapt this to be 2D, then I'm not going to be able to simply say if usernum is in table because the elements of table are lists. So I would essentially be saying is an integer in this list where every element is not an integer, it's a list. So that would always be false. Instead, I actually have to go visit each element in the list in order to figure out, or each element in the rows, the row list of the table list, in order to figure out if user num is in there. So the solution is a little bit trickier. What I'm going to do is I'm going to have a variable called found. And found is going to be a Boolean, which will initially be false. And essentially, I'm going to assume we haven't found user num in the table rows until proven otherwise. And the proven otherwise is going to come from iterating through each row and looking, is user num in this row? If we can find it in at least one row, then we found it in the table. And at that point in time, we'll set found to be true. So I'm going to have a for loop here, for row in table. And while user num is in the row, I am going to remove user num from that row. And if I ever make it inside of this while loop, meaning user num in row evaluates to true, that means that I did in fact find this user num in the table. So I'm going to set found to true. If there are multiple instances of user num in the table, then found will be overwritten with true multiple times, which isn't very efficient, but it's totally okay. So found is assigned true, make it overwritten with true multiple times, once for every time we have an occurrence of user num in the table. Now we have this else that is hanging here without an associated if. So what I'm going to do is I'm going to provide an if for it outside of the for loop and check the value stored in found. Remember, found is a Boolean, so it stores true or false. So if found, meaning if true, then it looks like we did find an instance of this user num in at least one of the table rows. So what I'm going to do is I'm going to call print table and pass in our table. That way, the user can inspect and confirm that in fact all instances of the number they entered are removed, and they can see what the current state of the table is. Now our else block here would execute when found is false, so not found, in which case we'll just print out, sorry, your number is not here. Let's run this and try it out. So this is our count code here. Let's do 10. This is our remove code here. Let's do 10 again. So now when I print out 10, I see the table. I do not see this little output right here on line 209 that says, sorry, your number is not here. So 10 was found, and we know that there were 4 10s. So if we look, we should have 4 rows that only have 4 elements, whereas before we had all 10 rows with 5 elements. So it looks like this one only has 4 now, this one only has 4 now, this one only has 4 now, and this one only has 4 now. So that'd be indexes row 0, row 2, row 5, and row 6. So let's just confirm before the removal. So row 0 did in fact have a 10, row 2 did in fact have a 10, row 5 did in fact have a 10, and row 6 did in fact have a 10. So it looks like our removal code works. Now I'm going to run this one more time, and this time I'm going to pass in a value that isn't in 1 to 10 inclusive, so it's not in the table. So maybe let's do 11. There's 0 of 11 in list, and I do 11, and it says, sorry, your number is not here, confirming that our found variable is working as it should. So to recap, we just solved several of our 1D list practice problems, again, using 2D lists. And the last note I have here is the same as my last note with the 1D list practice problems, which is for extra practice with functions, try solving this problem again using functions. So for example, this last solution here, okay, this could be a function called something like remove all instances. It would have 2 parameters, one which would be the table, the 2D list to remove instances from, and the second one would be perhaps the user number, And then we would require the calling code to either prompt the user for a number, or maybe get that number from command line arguments, or get that number from a file, or something like this, and then pass it in. So I would essentially put this code in the calling code and then pass in the value for user num as an argument to a call to a function where this is the body of the function. So try playing around with function solutions. Great practice. And that is the end of our 2D list practice problem. Hopefully you're feeling more confident working with lists. Thanks for watching, and subscribe to my channel for more Python practice problems.